Good morning, class. So I will be showing you how to perform the second part of experiment number 1. Again, we are still in kinematics. Okay, but this experiment we will focus on projectile motion. So what is projectile motion? So projectile motion is simply the combination of horizontal motion with constant velocity and vertical motion with constant acceleration. So if the object is moving horizontally, the x component of velocity is the same, so that is constant. And then object in projectile motion has also a vertical component, which is of acceleration, which is acceleration due to gravity. So the acceleration due to gravity in projectile motion is also constant. So that's equal to 9.8 meter per second squared. Okay, in this projectile motion, we'll be using this setup. Okay, this is called the projectile launcher. Okay, of course, this is used to launch the projectile at any angle. Okay, and then the projectile launcher can be set to different angles, but in our experiment, we'll be setting this one to angle 30 to 60 degrees. But in my case, I will be setting this to 40 degrees. Okay, and then we have here two Projectile heads. The Projectile heads will measure the initial velocity of the plastic ball. So the plastic ball is this one. So we'll be using the plastic ball as the projectile, our projectile. And then we have here the Projectile head cable connected to the digital adapter, and then connected, of course, to the GLX Explorer. Okay, and then the other digital adapter is connected to the other equipment that we'll be using, which is called the time of flight accessory. So the time of flight accessory is used to measure the time of flight of the projectile. Okay, again. We have the initial velocity that is to be measured by the Projectile heads, the time of flight accessory that will be used to measure the time of flight. Okay, we need to get the time of flight of the projectile and also the initial velocity for us to compute the horizontal distance and the vertical distance. So the objective of this experiment is to predict the horizontal and vertical distance of a ball shot at a different angle, or shot at this angle, which is 40 degrees. Okay, to start, okay, again, we need to set up this one. Okay, so the GLX need to be set up at the initial velocity. So the first quantity is initial velocity, then the second quantity is the time of flight. Okay, so we'll be using formula to compute for the vertical component, or the vertical displacement, and the horizontal displacement of the projectile. So written in your manual is the formula to get the horizontal component and the vertical component of the displacement. So for us to get the horizontal distance, the formula is simply VOXT, or the initial velocity, the x component of the initial velocity multiplied by the time, okay, the time of flight. And then for the vertical displacement, we'll be using the formula y is equal to VOYT minus 1/2 t squared. So that is also written in your manual. Okay, so let's start. Okay, the first thing is to set up the projectile at an angle. Again, the angle here is 40 degrees. Now, I'll be inserting the plastic ball inside the projectile launcher. Okay, we need to use the ramrod. So the ramrod is used to insert the ball inside. So the projectile launcher can be set to short range, to middle range, and the long range. But in our experiment, we'll be only needing the short range. And of course, we have there the carbon paper. So we have the carbon paper there, so that in every time that the projectile will land on the time of flight accessory, it will leave a mark. Okay, and then that mark will be used to measure the horizontal distance. Okay, start. Okay, I will just pull the string. Okay, and then there will be a mark here. So this point is where the projectile lands. Okay, so that mark. So this is for our first trial. And then for the data, okay, so the initial velocity is 3.11, and then time of flight is 0.72. So I'll be writing that here in the manual. So we have the initial velocity is the VGLX. Okay, so that's 3.11. And then we have time of flight. The time of flight is the TGLX. Okay, and then the value is 0.72. So So we will be computing for the y calculated, the x calculated, and the y measured, and also the x measured. So I will be measuring the horizontal distance. Okay, that will be in terms of meter. Okay, so from this point, so that is around 181.1. Okay, 181.1, or simply to convert that to meters, so let's just divide 181 by 100. So 181 divided by 100, so 1.81. So the horizontal distance here is 1.81 meter. Okay. So I'll be writing here the 1.81. So that's the x measured, 1.81 meter. Now the question is, what is the y measured? So y measured can be measured, of course, using steel tape. So that will be from the projectile launcher, okay, to the ground. Okay, so here is the reading. Okay, from this line, so that's 114.5, I guess. Or 115. So that's 115 centimeters. So 115 centimeters in terms of meter. So that is the y measured, 115, so 1.15 meters. Okay, now let's compute for the y calculated and x calculated before we proceed with the second trial. Because in the second trial, you just need to repeat all the formulas, all the procedure. Okay, again, we have the formula for the y calculated. So y calculated is simply boxt minus 1/2 gt squared. Okay, the box is the VGLX. Okay, the t here is the TGLX minus 1/2 GT GLX. Okay, so the box here is the horizontal component of the initial velocity, in which the formula there is simply BO multiplied by cosine theta, and then for the BOY, correction, this is BOY. Okay, so BOY is BO sine theta. Okay, here's the formula. So let's compute for the y. So the reading here is 0.72. So that is the TGLX. Then for BGLX, that's 3.11. So the VGLX is the VOY. So that's equal to the VO. Okay, so that's the VO. So this is 3.11. Okay, and then the formula for BOY is BO sine theta. So 3.11 meter per second multiplied by sine theta. So our theta here is 40 degrees. So that is set in the projectile launcher. So this is the BOY. Okay, BOY multiplied by TGLX. The TGLX is equivalent to 0.72 seconds. 0.72 seconds. Okay, minus 1/2. Acceleration due to gravity is the value of g. Okay, so that's the g, which is 9.8 meter per second squared. Okay, multiplied by, again, so that's the square of TGLX, or time. So TGLX is 0.72 second square. Okay, so the target is 1.15. So the measured value is 1.15. So as much as possible, let's hope that the value is close to 1.15. Okay, let's compute for that using our calculator. So we have 3.11 multiplied by sine 40. Okay, and then to be multiplied by the time, 0.72 minus 0.5, which is 1/2, multiplied by 9.8, and then to be multiplied by the square of time, 0.72 square. Okay, the answer here is 1.10. Okay, this is negative. Okay, why does the answer here is negative? Because the distance is below the starting point. So if the distance is below the starting point, the value is always negative. Okay, So this is negative 1.10. So our y measured is 1.15, or we can also put the negative. Again, the negative only shows the direction of the position, okay? So, or the displacement. So the displacement, it's below the starting point. So we have negative 1.10, okay? And then for the x calculated, okay, for the x calculated, so this is 1.10 meter. Okay, for the x calculated, the formula is VO x multiplied by T. Okay, again, our VO is equal to the VGLX, and then the T is equal to TGLX. So the formula will be VO multiplied by cosine theta multiplied by T, or this is BGLX cosine 40 degrees and then multiplied by TGLX. So let's substitute the value. We have BGLX is 3.11 meter per second multiplied by cosine 40 degrees, and then time, which is 0.72 meter, the second. Okay, let's compute the value. The value is 3.11 multiplied by cosine 40, and then to be multiplied by 0.72. Okay, the answer is 1.71.5 or 1.72. So this one is 1.72. Okay, so that's for the first trial. Then, so what we need to do is to do the second trial, the third, fourth, and fifth, and let's compute for the average value of the y measured, y calculated, and also the x measured and x calculated for us to get the percent difference. Okay, the percent difference has a different formula with a percent error. Percent difference is the difference between two values. Okay, so this can be any value. Okay, value 1 minus value 2. Again, this can be any value. It can be a displacement, it can be a velocity, it can be a position, or it can be any value. Experimental value 1 or experimental value 2 over the average of the two values. Okay, value 1 plus value 2, okay, over 2. Okay, so this is the average. Okay, then multiplied by 100. Again, this is absolute value. Okay, so this is how to get, okay, the percent error. Okay, I will be continue to get the trial 2, 3, 4, and 5. Okay, I will insert the plastic ball again inside the projectile launcher. Okay, so this for the second trial. Second trial. Here is the point. Okay, this one. And then the reading is so that's 1.80 or 180.7. 180.7 is that's also 1.81 if we're going to run off that one. Okay, so that's also 1.81 for that's for the second trial. And then for the data, okay, so this is also 1.81, and then we have 3.10 also 3.10 for the initial velocity, and then for the time applied, that's 0.72. Okay, I will be collecting first the value of the data, and then after that I'll be computing for the y calculated and the x calculated. And of course, the way you measured here, the y measured is the same, that is constant. So we have 1.15. The reason is because we are not changing the setup. Okay, we are not changing the vertical position of the projectile. So that will be the same. They are all negative 1.15. Okay, second setup or the third trial. This is now the third trial. Okay. So the third trial is here. So here's the data. Okay, I think this is the first, the second, and then the third one is at the mid of first and second. So the reading of the first and second is 1.81. Obviously, the measured value there is also 1.81. Okay, so the reading in the GLX is the same. So the reading in the GLX is also 0.72, and then also there, that's 3.10. So we have, this is also 1.81. Okay, now let's proceed with the port trial. Okay, so the support trial. Let's measure the horizontal distance. Where are you? So the port is here. That's also between 1 and 2. So obviously the reading is also 1.81. Okay? So that's 1.81. And then the reading on the GLX is, okay, that is also 0.72 and 3.10. Okay, now let's proceed with the pit trial. Okay, so last trial. Okay, that's it. So where is the pit? Where's the pit point? So the pit point is here. I guess here, the last one. Okay, this 1.80.5, if we're going to round off that one. Okay, so here, that's 180.5, so that's also 1.81. Okay, so we have the last trial. This is 1.81, and then based on our GLX reading, okay, that's also the same. Okay, this is also 0.72, then this is also 3.10. Okay, now let's compute for the Y calculated and X calculated. And then obviously our reading for the 2, 3, 4, 5, since we have the same value, the Y calculated and the X calculated will be also the same. Okay, we will get the same answer for that, for the Y value and the X value. Okay, we have, again, let's compute for Y calculated. Okay, the formula is again BOX or BOYT minus 1/2 GT squared. So BOY is simply BO sine theta T minus 1/2 GT squared. Okay, again, as what I mentioned a while ago, BO is the VGLX, the T here is the TGLX. Okay, so let's substitute the value. So BO is 3.10. So that's 3.10 multiplied by sine 40 degrees. Okay, we are not changing the angle. The angle is always set to 40 degrees. So it's up to you if you want to change the it's up to you if you want to change the angle to different angle. But according to the procedure, it should be set to 30 degrees to 60 degrees. And then TGLX is 0.72. So this is to be multiplied by 0.72 minus 1/2 times 9.8 meter per second squared. So this is in second. And then TGLX is 0.72 second squared. So let's compute for that. Okay, that's 3.10. Then sine 40. Okay, multiplied by time 0.72. So that's the reading on the GLX, the TGLX. Okay, minus 0.5 multiplied by 9.8 as the value of acceleration due to gravity, 0.72 square. So the reading here is 1.10, 1.105 or negative 1.11. I-round off natin. Let's round off that to 2 decimal places. So this is negative 1.11. Okay, and then for the X calculated, so we have the BGLX cosine theta and then TGLX. So VGLX again is 3.10 meter per second cosine 40 degrees multiplied by TGLX 0.72 seconds. Okay, so we have 3.10 multiplied by cosine 40 and multiplied by TGLX 0.72. So this is 1.709 or 1.71. So this is 1.71. Again, I hope we'll be getting the low percent. Anyway, we're just computing for the percent difference. Okay, that's not percent error. Negative 1.11. This is also 1.11 because they have the same value naman. So we will be computing for the same value for the x and y. Now I'll be computing for the average value. Okay, so the average is simply the sum of all divided by the number of trials. So we have 3.11 plus 3.10 times 4. Okay, divide by 5. So the answer is 3.10102. So this is 3. Where's what happened? So that's the average. Okay, I'll be computing for the average here. Sorry, the y. Obviously, this is negative 1.15. This is obviously 1.81. And then I guess this is also okay. I'll just be showing you, but we already know the answer. Divided by 5. So this is 1.108 or 1.11. Negative 1.11. This is obviously that will be also 1.71. 1.71 times 4. Okay, plus 1.72 divided by 5. So this is 1.712 or 1.71. Okay, let's compute for the percent difference. Okay, for the percent difference, let's use this formula again. Okay, so this is the formula. Okay, so that will be, so value 1 minus value 2, we have these two values. The first value is 1.15. 1.15 minus 1.11. Okay, all over the average of the two values, 1.15 plus 1.11 divided by 2. Okay, and then so the answer is 0.353 multiplied by 100. So the percent error is 3.54. Okay, so that's very low. Okay, so we got the target percent difference should be 10% below. Okay, for the other one, this is 1.81. Okay, minus 1.71 divided by the average 1.81 plus 1.71 divided by 2. Okay, then the answer is to be multiplied by 100. Okay, that's 5.68. So the percent difference here is 5.68. Okay, so this is how to do the experiment number 1. The second part, which is projectile motion, and then for the first part, which is free fall motion. So we already computed for that in the first video. Okay, for this experiment, I want you to solve the number 1, number 2. Okay, you just need to be applying the equation for motion. Okay, and then in number 2, you just need to answer here, is the magnitude of the acceleration greater while it is being thrown upward or as it falls? Okay, I told you before that the acceleration due to gravity is constant. Okay, regardless if the object is going up or going down, so that will be always constant, and then the value of that is 9.8 meters per second squared. Okay, so the answer for number 1 is that what I told you. Okay, so you need to explain that one. At the same instance that you fire a bullet horizontally from a gun, you drop a bullet from a height of the barrel. If there's no resistance, which bullet hits the ground first? Explain. Okay, you just need to apply here the formula for the free fall motion and for the projectile motion, and then the target here is to get the distance. So we have here the formula for distance. If this is free fall, the first one is free fall, then the second one is the bullet is horizontally from a gun. Okay, horizontally, meaning if the object is moving horizontally, purely horizontal on a projectile motion, we can conclude that the BOY is 0. So BOX is the value of the horizontal velocity. Okay? Ganun lang sa problem. If you encounter in a problem that states that the object is moving horizontally in a projectile motion, automatic the value of the of the y component of the velocity is 0. Okay, so in this case, you just need to use the formula. So this is the formula for the for the y component, BOYT or BOT minus 1/2 GT squared. So this is pre-pole. So obviously the formula will be 1/2 GT squared. Okay, negative. This is also negative. This is negative because this is below the starting point. Okay, here to compute part T, that's simply 2y over g. Okay, this is the formula to get the time in the pre-pole. So this is pre-pole. For the projectile motion, almost the same formula. Kaya lang, you just need to include the y subscript. Okay, this is also 0. So if this is also 0, you will arrive on the same equation. So meaning we can say that the time for the bullet to hit the ground in horizontal motion is the same with the time that the bullet will hit the ground in a pre-pole motion. So they are the same. Okay? So that's all for experiment number 2. So if you have any questions, don't hesitate to ask your concern or to raise your concerns to your professors. Okay, thank you so much.